We now invite you to sit back, relax, and enjoy today's presentation. It is my pleasure to introduce your moderator for today, Nicole Adams, Communications Director at Westport. Nicole, you now have the floor.
Thank you, Kara. Hello, everyone, and thank you for joining us for CNG and LNG, What's Best for Your Fleet, with Westport and Clean Energy Fuels. As Kara mentioned, I'm Nicole Adams, Communications Director at Westport, and I'll be your moderator today. Our speakers today are John Howell of Westport and James Harger of Clean Energy Fuels. Even as more and more fleets across North America are switching to natural gas, fleet operators and managers have questions about how to make the right fuel choice for their fleet. And this webinar will provide information to help you decide what natural gas fuel is the best for your fleet. Two of North America's leading natural gas experts will be speaking today. John Howell, Senior Director of Marketing at Westport, started his career as an industrial engineer with General Motors and progressed through manufacturing, engineering, product planning, and marketing assignments with multiple divisions of the company. He has worked as an automotive product marketing executive in the U.S., Europe, and Latin America, and was responsible for the global product portfolio of Cadillac for 7 years. John completed Master of Science in Industrial Engineering and Master of Business Administration at State University of New York at Buffalo. Jim Harger, Chief Marketing Officer with Clean Energy Fuels, has been involved in the natural gas business for over 25 years. The past 16 years dedicated to marketing natural gas vehicles and building fueling stations. Previously, Jim worked for the Southern California Gas Company the last 5 years on the market development of NGVs. In 1997, he left SoCal to join Pickens Fuel Corp as Vice President of Marketing. He was the company's second employee. Jim received a Bachelor's of Science degree in Civil Engineering from UCLA and a Master's degree in Business Administration from Pepperdine University. Here's an overview of what we'll be covering today. The case for natural gas as a vehicle fuel, 7 factors to consider in choosing the right fuel, CNG-LNG comparison, fueling considerations, application considerations, and payback analysis. If you have questions during or after the presentation, please do use the Q&A panel to send us your questions. John and Jim will answer your questions when the presentation is finished. And in case we're not able to get to your question in the allotted time, we'll be sending out a complete list of questions and answers to today's participants. I'd now like to turn the presentation over to John.
Thank you, Nicole, and welcome everyone today. We're very glad that you were able to join us to talk a little bit more about natural gas and specifically the 2 different types of natural gas that are available for transportation use, liquefied natural gas and compressed natural gas. Today, more and more fleets are choosing to move to natural gas as their transportation fuel. Every day, it seems, there's another announcement of a fleet or a company that's decided to make this transition. And primarily they're doing this because of the economics involved. Natural gas is less expensive than diesel or gasoline, and in fact, almost, I think we could say, the least expensive fuel that's available in the marketplace. In order to use it, as fleets decide and make their decisions, it's important to consider the right factors as we move forward, and to look at the type of engine system that's important, to look at the fuel choice, and there are some differences here, and of course there are many other opportunities for people beyond natural gas, but we'll be talking about that today. And then there's a couple of different choices with respect to how natural gas is stored. So we've divided this down into 7 different factors in making an informed decision about fuel, specifically for LNG and CNG. You need to look at your vehicle type and its application and understand that very specifically, and look at the advantages and disadvantages of choosing either LNG or CNG for that vehicle type. The duty cycle, including the range, speed, idle time, and other factors are something that need to be looked at carefully, and we'll talk about that a little bit more here. The combined weight, the payload of the vehicle, whether it's weighting out or cubing out in its application, and then what the impact would be on that specific application in terms of weight for the storage tank, the fuel tank, and its weight as well as its contents. The hours of service, it makes a difference, of course, how long the vehicle is being driven each day, what its downtime looks like, how much it's idling, and these need to be taken into account as well. As you make the decision, you'll obviously be looking at fuel costs and the savings that are achievable versus diesel fuel, or in some cases potentially gasoline. Your fleet fueling needs in terms of refueling cycles, how often the vehicle needs to be refilled, and who is doing it, and the amount of time that's available to do that needs to be taken into consideration because there are some differences in the two fuel types. And then finally, and probably most importantly, the fueling infrastructure that's available to you and available along your routes is going to largely determine what is best in terms of the choice available. Just a little bit of definition. The CNG and LNG are really simply two different ways natural gas is stored. There's really no such thing as an LNG or CNG engine. We see this written a great deal, but in many cases, and we'll talk a little bit more about that as well, it's simply a choice as to how the fuel is stored on board the vehicle. The engines, generally speaking, will be able to run on methane, which is always a gas, and it's delivered to the engine as a gas. If it's stored on board the vehicle as CNG, as a gas, it doesn't need to be regasified. But if it's stored on board as a liquid, then there is a process for returning that liquid to a gaseous state before delivering it to the engine. So that's just a distinction to help people think about this. The engines themselves are relatively agnostic to the fuel type, and this would apply also to other forms. If people consider biogas or something like that, would apply to this as well, that the engine doesn't really care how the gas is stored. It always uses it in the form of a gas, not in the form of a liquid. So LNG is a cryogenic liquid. It's natural gas that has been reduced in temperature to minus 260 degrees Fahrenheit, or a little over 162 degrees Celsius below zero, and that's at atmospheric pressure. Whereas CNG is still in its gaseous state and stored at high pressure in a pressure vessel, and generally speaking, non-North American or past standards have been at 3,000 psi, and the current North American standard is at 3,600 psi for a full tank, and we would use that pressure all the way down to lower pressures, to the rail pressure of the engine before the tank is empty. Both CNG and LNG are less dense forms of energy than petroleum-based liquid fuels. NGVs have to have larger fuel tanks to store the same amount of energy. And you can see on this chart, as well as on the following page, it's pretty easy to make a comparison. LNG is a little more, it requires a little more than half the same amount of, or contains the same amount of energy and a little less than half the amount of space. And CNG is it takes about 3.5 times as much space for CNG to yield the same amount of fuel as gasoline, and about 3.8 times for diesel fuel. Here's another way to look at it, the other way around. Liquefied natural gas, a gallon of liquefied natural gas is, you need 1.7 of them to make a diesel gallon equivalent, and about 3.8 times as much CNG to make a diesel gallon equivalent. And this is on a volume basis. Energy density is a factor that you need to consider when choosing a natural gas vehicle. This is not a factor in terms of running the engine or the amount of power the engine can put out. It's simply a question of how much storage space is required on board the vehicle. So I'm going to turn it over to Jim right now, and he's going to talk a little bit about fueling considerations.
Well, thank you very much, John. Welcome, everybody. I'm going to talk about CNG and LNG, but before I begin, I want to make sure that you folks are familiar with our company and what we do. We're the largest compressed natural gas and LNG fuel provider in North America. 70% of our sales are compressed natural gas, 30% are LNG. We're on a run rate of in excess of 200 million gallons in sales per year. And we also own a compressor company that builds the CNG compressors and dispensers, as well as an LNG station builder. So we have a lot of experience, and I want to make sure that as I go through the slides, it's an unbiased opinion because we think both fuels have their place. Looking at this very elementary graph, just starting at the right, natural gas that's provided for most compressed natural gas stations is provided by the local distribution company or utility. It is dried. We remove water vapor in that first cylinder there. We compress the gas into the storage vessels at 4,500 pounds and then deliver to the vehicles through a dispenser at about anywhere from 3 to 8 gallons per minute, depending on how much horsepower and capacity we have on the compressors, until the vehicles are topped off at 3,600 psi. Next. We believe that compressed natural gas is best suited for vehicles that really drive less than 250 miles per shift or per day, or burn less than 40 gallons of fuel. As I see here, I've already mentioned that in most cases, natural gas for these types of applications are delivered by the local distribution company. On our LNG stations, they're all designed to provide compressed natural gas, so we can compress a liquid and actually make CNG. So the highway stations we're building will provide that service at a future date. As I mentioned, on a large station, we can dispense at about 5 to 8 gallons per minute over the fill. But one of the more important points to realize is that when you look at a large truck or bus or trash vehicle, when you look at the weight that's added for CNG as compared to LNG, gallon for gallon or BTU for BTU, the weight impact of CNG is about 4 times that of LNG. So if you're weight sensitive and doing bulk hauling, you're going to lose payload capacity by using a CNG application versus LNG. Next. The best application for CNG is what we call a time fill, where we basically fuel each of the vehicles individually in parallel, like in the pictures below. These are 2 solid waste projects that we built. One is in Seattle on the left, and the other is in Livermore, California on the right. Today we fuel about 6,000 refuse trucks this way. We started the refuse industry back in 1997 with this type of application. Today, Waste Management and Republic Service are 2 of our larger clients. We build most of their stations. And because of the economics, Waste Management and Republic are buying in excess of 80% of their new purchases in CNG. And where the CEO, David Steiner of Waste Management, has said, if I can buy CNG and I have gas available, that all of our replacements going forward will be natural gas. It's the best value for a individual or a proprietary considering natural gas. So if you park your vehicles overnight, this is a great application. It's cost you less for the equipment. You're also able to get a full fill, which we'll talk about here in a little bit. All the heat that's gained during a compression process is dissipated because you're filled over a 3 to 6 hour period. So when the trucks leave each morning, they're going out at a full capacity to meet their daily route with reserve. Next. Next. So conversely, on a fast fill, and this is a photograph of our station in Boston. We're fueling a couple hundred buses at one of the facilities there. We actually have 3 stations in Boston serving the transit operation. And then the bottom is the Fair Oaks Dairy Project, where we're fueling between 40 and 50 tractors a day that are running bulk milk to processing plants south of the Fair Oaks Dairy. One thing about when you fast fill a vehicle, you gain a lot of heat through which you might remember in your chemistry days, the ideal gas law. if you fast fill a truck with more than 80 gallons, when the gas cools off, you're going to lose about 20% of the available capacity, as compared to time fill that I mentioned earlier, where you will be able to get a complete fill. Stations that will be able to dispense 4 lanes at 10 gallons per minute simultaneously will cost $5 million or more. And you'll need about a half acre of land. So these are some of the challenges of a CNG station. Public utility services, you're going to need a minimum of 100 PSI pipeline capacity to be able to deliver that kind of speed at the dispenser pump. And you're going to need about 2 megawatts of power, enough power to run 2,500 horsepower of electrical motors. And that's going to be extremely costly just for the privilege of turning that system on. Any day of the month is probably going to result in about a $30,000 per month demand charge. So again, unless you've got a high use and a number of buses or trucks, that demand charge will have its severe impact on the overall cost of your price of fuel. So when you look at station for station, 4 lanes, fueling at 10 gallons per minute or more, the cost of a CNG station will be almost 2 times, maybe 3 times more than that of a comparable LNG station. Next. One of the points also, and it's a misnomer or misinformation in the industry, is that when you look at the number of stations across the country, you'll see close to 1,000 of them. And when you start drilling down, a lot of them will look like this station here, which is directly across the freeway from our offices. It's designed to fuel taxi cabs and light-duty vehicles, not trash trucks and buses and other types of large vehicles. The station here probably dispenses at about 2 to 3 gallons per minute, which is fine for a light-duty vehicle application. But for this trash truck that needs a midday fuel, he'll be there for 15, 20 minutes just to put on maybe 20 or 30 gallons of fuel. And that's the reality at most of the facilities across the country. Next. So let's talk a little bit about LNG. LNG is different, and as John pointed out earlier, it's just the way that we store the fuel on board the vehicle. We can store LNG because it's substantially more dense as a liquid than it is as a gas, so you can get a longer range between fill-ups. LNG is essentially supercooled at a liquefaction plant and then delivered over the road in a tanker trailer like you see on the left, dispensed in a bulk tank, which are typically vertical, and then dispensed in the vehicle all as a liquid. And this is almost transparent as diesel fuel. So at most of our LNG stations, we're dispensing between 15 to 20 equivalent diesel gallons per minute, just like diesel fuel. Next slide. So when we look at the applications for LNG, it's really high use, daily use, driving more than 250 miles per day, in at least 5 to 7 days per week. The liquefaction, one of the negatives, to supercool the fuel impacts the fuel price by about 50 to 75 cents a gallon. I mentioned earlier we're dispensing at similar rates to diesel, so 15 to 20 gallons per minute. And as you can see here, it's very similar to the chart before, the fuel is supercooled at a liquefaction plant, delivered over the road in a tanker trailer, stored in the bulk delivery tanks, and then dispensed into the vehicle, all as a liquid. In the far right-hand corner, one point to make is that LNG, you need to wear safety glasses and also gloves when you dispense the fuel. As compared to CNG, you need neither of those pieces of equipment. And then the last impact to LNG is at the liquefaction plant relative to the end-use customer, we're impacted by over-the-road transportation. So the farther the distance from the liquefaction plant, the higher the impact on the fuel cost. So we like to have the liquefaction plants to be within at least a 250-mile radius of the end-use customer. Next slide. So, quick summary. Diesel, now LNG compared to diesel, transparent in terms of the fuel time. So hours of service will not be impacted for a fleet. Stations can be expanded without utility constraints. Remember, a CNG station, you have to design the pipeline capacity and the power requirements for the compressors. But if you want to add, you better have excess capacity to be able to add the extra compressor and electric motors, which sometimes are constrained. We can store twice as much energy volume compared to CNG. And when you look at the weight, LNG, when you look at a weight for a bus or a trash truck or a truck that has at least 120 gallons of fuel, LNG weighs about a quarter of the similar amount of capacity as CNG. One of the negatives is that you have a shelf life for LNG. It'll boil off if it's not used. So beginning about the 5th to the 7th day, if the truck has not been used, we'll start creating pressure within the tank. Typically, the tanks are set for 250 psi. So if the vapor inside the tank reaches a 250 psi limit, it'll start to vent. The way you prevent that is you have to essentially go out and start the engine and take that gas and burn it in the engine for a few minutes and then lower the pressure within the tank and then start the process all over. So there's some management there if the vehicles aren't used on a regular basis. And then lastly, unfortunately, LNG is taxed at a higher rate from a federal basis. We actually have legislation that we're now trying to get passed to bring LNG into parity with diesel fuel. So today, LNG on an equivalent diesel basis is 41 cents a gallon compared to diesel at 24. And then there's several states across the country, 5 of which we have just recently corrected, but there's another 24 that we're working on to put LNG on an energy basis in parity with diesel fuel. And then lastly, sales tax. There are some states that impute sales tax on LNG like diesel fuel because it's delivered over the road. With the exception of Georgia, CNG is exempt from sales taxes. Next.
Okay, I'm going to take it back over here and talk a little bit about applications for CNG and LNG from the truck side perspective. There's kind of a continuum when you look at the vehicles that are out there, and choosing between the two really is something that you need to, again, think about your application. And if you're at one end or the other of the spectrum, you really don't have a lot of choice. It's a relatively fixed decision. For heavy haul and very large vehicles, most of these are going to run on HPDI type systems that are designed for very high fuel system pressures and therefore are designed to run on cold LNG. And so your decision is you don't really have one at the far right side of this. And by the same token, for light duty vehicles with smaller fuel tanks that are running with low system pressures, those vehicles are primarily all CNG. And when you're only storing a relatively smaller amount of fuel on board the vehicle, it really is less expensive to do it with CNG in terms of the tank than it is with LNG. LNG, there's a crossover point where LNG tanks get to be less expensive than CNG tanks as the volume of fuel that needs to be stored goes up. And so that brings us to the middle category. And when you're in kind of the vocational area, and even to an extent in the bus area, but definitely when you get into Class 7 or even the lower ends of Class 8 vehicles and vocational vehicles, you can get to a point where you can decide whether you want to store your fuel as CNG or LNG. We'll talk a little bit more about that. CNG is a great choice for refuse and transit based on what Jim was saying. If you've got vehicles that are being stored overnight and not driven for portions of the day, using a time-fill CNG system is a very practical way to go. And so we find that trash trucks and transit buses generally operate this way, with maybe fast fill as an option to quickly fuel them up if they do need that during peak demand times. Medium duty applications are good for less than 300 miles per fill, and this is another possibility for vocational vehicles or plows or other municipal type equipment. LNG is a good option for long driving ranges and engines that are used for hauling heavy loads. And again, when you get into that middle section, we would differentiate somewhat the spark-ignited engines from the HPDI engines, and it's really the spark-ignited engines where you've got this choice of storing either as CNG or LNG. So, to help evaluate, you need to ask yourself the amount of energy your vehicles require and how often they need to be refueled. And it's very important with the cost of fuel storage being one of the most expensive parts of making your decision about purchasing a vehicle, that you evaluate this closely and essentially not buy more storage on board the vehicle than you need. Again, it's very expensive. So look at your application and buy the amount of storage that the application requires, or maybe just slightly more so that you've got some backup. But basically, don't buy a lot more than you need because you'll overpay. Vehicles that need to be refueled frequently, this needs to be taken into account as well. And as Jim said, LNG can be a good choice because fueling times with large capacities of onboard fuel are generally faster with LNG than they are with CNG. You need to look at the number of hours that a vehicle is in use per day and the number of hours a vehicle is driven every day. And with slip seat operations where multiple drivers are using the same vehicle and need to refill it quickly, again, LNG may make more sense than CNG. If there's available time in the day to refill and fast fill CNG is available to you, that can work as well. LNG is an attractive solution if you're in constant operation and need to be refilled quickly, and I think that's the basic message here. So, as Jim said too, I wanted to reiterate that there is a shelf life for LNG in kind of the 5 to 7 day range. It's a bit of a discussion that is somewhat not that important because most assets like this are not sitting parked for 5 days or 7 days or longer. If your vehicle assets are sitting parked, you have another problem. And basically, people using these vehicles generally find that they're using the fuel very quickly. It's part of the entire payback process here. So venting really is only an issue that's somewhat theoretical. The weight difference between the various tanks that are involved here is something that can be substantial. Diesel tanks are typically just welded sheet metal, stamped metal. Gasoline tanks are sometimes blow-molded plastic. When you look at an LNG tank, you're looking at a double-walled stainless steel cryogenic cylinder. It's heavy and requires heavy mounting brackets and capability. And with CNG cylinders, you're looking at very heavy-duty, typically composite, but sometimes steel cylinders that are mounted in steel racks for safety and cabinets that surround them to protect them. And so the weight for these things can go up quickly. At the bottom on this chart, you can see this isn't weights, but basically volume that needs to be contained. So for 15 gallons of diesel, you'd need about 26 gallons of LNG, or about 58 gallons equivalent. Again, this is volume, not weight of CNG. So they take up progressively larger amounts of space, basically. So ask yourself how much tank weight you can afford. Again, based on your application, don't overbuy because you are adding weight to the vehicle, and you need to evaluate your use case. An example here, an LNG tank that provides 60 diesel gallon equivalents of storage weighs about 1,100 pounds when full. When we look at CNG tanks to store 60 DGEs, with fast fill capability, so we're actually having to add a little more capacity there because they're only about 75% usable. That amount of capacity of storage on board the vehicle is going to weigh about 1,600 pounds. And you have to ask yourself for your application, is that 500 pounds important to you? Are you maxing out on the load of the vehicle before you max out on the cube for the vehicle? And what does that 500 pounds mean to you? And then you have to also ask yourself how much space the tank will require. LNG tanks are typically mounted about in the same position as a standard diesel tank in a side saddle location. CNG pressure vessels can be there, but they're also typically packaged in steel racks behind the cab. This can sometimes drive longer wheelbases or changes in turning radius for the vehicle based on wheelbase that can have an adverse effect on the application, so that needs to be considered as well. This chart just shows some very basic measurements here of LNG tanks in nominal sizes versus CNG tanks. And we've tried to equalize this more or less with effective diesel gallon equivalents. There's two examples at the top, 60 and 75 DGEs, and then at the bottom, 62 GGEs. And we're trying to just sort of bracket that there. And you can see that both in terms of the dry weight of the tanks as well as sort of the net weight of the vehicles, we actually can come in, if you take into account on the LNG side the weight that the vehicle carries for its emission system and urea storage, and you subtract that out as being unnecessary with CNG, we can actually come in with weights for LNG that are below the diesel equivalent. Very difficult to do that on CNG, and as you can see on the bottom row, we're estimating here a little over 500 pounds of net increase, again, to store 62 DGEs or a nominal size of 82 DGEs as CNG. Your return-to-base fleets, as we said earlier, are very good candidates for CNG. You can install infrastructure, and as Jim pointed out, that infrastructure can be designed to meet your needs, whether it's fast fill or time fill. And that's a very easy way to do this if you can fuel your own vehicles and control your own fueling. Time fill is very attractive, as we've mentioned, and is less complex and less costly. Doesn't require storage, and the compressor is usually smaller. And then fleets that need to operate around the clock or that are using slip seat drivers really need some kind of a fast fill option, either public or private, and that can lead you down the path to either fast fill CNG or LNG. So I'm going to turn it back over to Jim at this point and talk a little bit about station investment.
So this is a chart we put together because there's a lot of misinformation on price across the country. You know, when you look again on any of the websites and you see fuel selling in Utah or Oklahoma for $1 a gallon, you get what you pay for, and typically those stations that are operated by the public utilities are dispensing between 1 and 4 gallons per minute, which is great for a light-duty vehicle or a passenger car, but certainly not for a heavy-duty truck. And this stair-step starts to amortize what we call the capital equipment and operating costs that I mentioned earlier for a real fast fill station. So if you look at a station wanting to dispense between 6 and 10 gallons per minute for CNG, and you start amortizing a $5 to $7 million investment plus the cost for electricity, the cost of fuel is going to be probably closer to $2.50 per gallon. So just something to consider when you make the comparison of an online look at a utility station that's capable of fueling at less than 4 gallons per minute to reality for your fleet that really needs to fuel similar to diesel upwards of 10 gallons per minute. Next slide. Another factor is hours of service. And as you know, there's another half hour that will be deducted as of July 1st to our drivers that do over-the-road transportation. When you look on a fill rate, an average fill rate for a large CNG station, which is closer to 5 to 6 gallons per minute over the fill, compared to an LNG station that's fueling between 15 and 20 gallons per minute, when you look at the number of hours per year for the number of miles that they drive, so this chart here shows on the y-axis gallons per minute, and on the bottom gallons per year or miles per year. When you look at that impact for a 100,000 mile a year fleet, which burns just less than 17,000 gallons, the fuel time savings at the pump is almost 1 week of work. So again, when you look at hours of service being impacted, LNG provides another benefit in terms of the speed at which we get the trucks in and out of the fueling station. Next slide. So let's look at the infrastructure. Today, across North America, we have a very robust LNG infrastructure that's growing. Today, as I mentioned earlier, there's at least 1,000 public access CNG stations, but more than 90% of them are not conducive to fueling trucks or trash trucks or buses because first of all, they can't get them in and out of their aprons, nor can they fuel them at a rapid rate. They would be there for a half an hour to 45 minutes to fuel. There's great networks in California, New York, and Utah, and Oklahoma, Arizona, Texas, and Colorado. Again, most of those are designed for light-duty vehicles. There's a robust infrastructure being built by several people in the industry, Shell, ENN/Blue Energy, our company, that have plans to build in excess of 230 stations by the end of 2013. Today, our company has 76 complete, with 15 of those open and another 25 in construction. But these are all spaced about every 250 to 300 miles, so that on a single tank trucking configuration, we can go point to point with ease and have sufficient reserve. Next slide. And this is a layout across North America of what's currently open. Those are the green diamonds. What's built and is in preparation for the 12 and 15-liter trucks that will be out later this year, and then what's also planned to be constructed by the end of this year. So pretty darn good infrastructure to run coast to coast, border to border, along most of the interstates across the United States. Next slide.
Okay, I'm going to just spend a few minutes here on payback analysis and look at a couple of examples. The first one is just a quick look at fuel prices themselves, and what we've done here is to display GGEs, gasoline gallon equivalents, and DGEs, diesel gallon equivalents, as well as million BTU prices amongst the various fuels that are available out there. And we started with prices from the Clean Cities Alternative Fuel Price Report, which is a national average of retail pricing. It's highly variable depending on what part of the country you live in. But on a national average basis, you can see at retail what the prices look like. And I think the most important point from this chart is that when comparing natural gas in either form to the other fuels that are available, it is substantially less expensive. In most cases, there's at least a 50% difference. And in some cases, against some of the more expensive fuels, it can be even more than that. So a lot of potential savings for people. And it is important that everyone understand that while pricing is sometimes in gallons for things like E85 or biodiesel, you have to look at the energy content of the fuel and understand what that means in terms of the amount of energy you're buying. And they're all variable, except actually CNG and LNG, which are sold typically in units that mirror either diesel fuel or gasoline, or GGEs and DGEs, so to speak. So a quick look at a very light-duty application here would be pickup trucks with the Westport Wing bi-fuel system. Basically, our assumptions are that these vehicles would be kept for 5 years, and they would drive 30,000 miles a year, which is not unusual for many fleets. They get approximately 15 miles per gallon, and our upfront incremental cost right now on a sort of suggested retail basis is $9,500. We're using a gasoline price of $3.46, which is about average for the country, and a CNG price of $1.29. And we're looking at fuel savings on this basis. When you make that calculation of 15 miles per gallon into 30,000 miles times the fuel cost difference of about $4,344 a year. So your investment for these trucks pays back in about 26 months, and your total fuel cost savings over the 5-year life cycle is $217,000. It's a very large sum of money. So this is it's a great application with approximately a 2-year payback. again, under these conditions. You can go and look at payback calculators for the specific conditions that you find your fleet in. And then another one here, and we kind of go all the way the other direction, is to the Westport 15-liter HPDI engine, and looking at that in a Class 8 PACCAR truck. Again, a 5-year length of ownership for these 10 trucks. Trucks accumulating 120,000 miles a year and getting about 6 miles per gallon. Incremental cost for the HPDI system we've shown here at $65,000. I would like to point out that the other options, particularly as they apply to people that might want to consider CNG, would be the spark-ignited engines from Cummins Westport. There you've got an 8.9-liter ISLG, and with 60 DGEs of storage, I think we could probably project an incremental cost of only about $30,000 to $35,000. And for the new ISX 12G with 100 DGEs of storage, I think we could project a price there probably in the $50,000 to $55,000 range. Again, it's very highly variable and very dependent on the amount of fuel you need to store. But I don't want to give the impression that $65,000 is necessarily the absolute amount that an over-the-road truck would cost. We'd use diesel fuel at $3.95, LNG at $2.45, and on this basis, a per-truck savings per year with that mileage, that fuel economy, and that fuel cost differential is about $30,000. Payback at that rate, for even at $65,000 acquisition costs, would be under 3 years, 2 to 2.5 years. And total life cycle savings is, again, very substantial, $850,000 over 5 years for 10 trucks. So, again, there's a tremendous amount of opportunity here for businesses that are considering natural gas as a fuel. So I think that kind of wraps us up. I know there are some questions, and I'm going to turn it back over to Nicole and let her go through some of the questions and ask either myself or Jim or both of us to comment on those, and we'll be happy to do that. I think we've got about another 15 minutes or so on the call at this point.
Thank you very much, John. The first couple questions seem to be for me, so I'll start with those before I turn them to you guys. A number of folks have asked whether or not a copy of the presentation will be available for viewing later. Yes, we've recorded the presentation. We'll be sending out the list of the Q&A to everybody, along with the links to the recorded presentation after we've finished up. Other people have asked if they have any questions, can they contact us? Absolutely. John and Jim's email addresses are available there on the screen right now. And if you wanted to contact me, it's media, MEDIA, @westport.com. I'm going to throw John his first question as well. John, can you please confirm the temperature of LNG? I thought it was colder than that. How does LNG stay at 260 degrees Fahrenheit for a week? Are the tanks insulated?
No, it's 260 degrees, and that's about what it comes out at atmospheric pressure when it's stored after it's made in a liquefaction plant. Typically, we see it when it gets to a station and it's stored at a station is maybe in about the 240 degree negative, that's Fahrenheit. And then it's used at the station and dispensed at the station at approximately that temperature of minus 240, sometimes a little bit colder than that. The colder the better, because the colder it is, the denser it is. And then there are some fuel tanks, and we didn't spend time on it today here, but there are really two different types of storage systems for LNG. One uses warm fuel, or relatively warm fuel, that's at about 200 degrees Fahrenheit negative, versus the colder fuel, which is at about 240 negative. And this warm or saturated fuel is important for some tank systems that operate on vapor pressure as opposed to using a pump. And again, we didn't talk about that today, but that could be the subject of a future webinar, I suppose.
Thank you, John. Jim, the next question is for you. Are there special fire protection requirements for CNG and LNG filling stations?
You know, each area has certain code requirements, so we have to meet federal, state, and local. But that's something that we would address on the specific site. But the answer to your question is yes, and they're different from region to region.
Okay, thank you very much, Jim. Next question is for John. What are your expectations around cost advantages for natural gas vehicles for the next decade?
Oh, well, it's a great question, and it really depends, I think, on people's point of view about the overall macro-level supply of natural gas versus petroleum. And certainly there's a great number of people that are involved in trying to predict long-term energy prices. I can give a personal opinion there that the shale gas revolution, both in the United States as well as globally, is probably going to lead us to a situation where we have a very abundant supply of natural gas. And whenever, at least in classical economic terms, you have an abundant supply of something, normally prices are well contained. So the same might be said of petroleum, and we've seen actually increases in the recoverable reserves of petroleum over time as well, but they're not growing at the same rate that natural gas is. And so I think the expectation of most people is that the differential that we see today between natural gas and petroleum-based fuels will hold and will maybe even be enhanced somewhat over time. It's difficult to tell, but again, global supply for natural gas is huge, and that should help contain prices over time. And it looks like there's generations of possible supply.
Thanks a lot, Sean. Jim, next question for you, please. Is there a reason that public CNG stations are not built or scheduled to be built in Minnesota?
You know, there are some stations that are being, I saw that question, that are being forecasted by Quick Trip. And Quick Trip is a very large gasoline and diesel provider in the 4 northern states. And if you go to their website, I believe you'll see quite a few stations that are planned for the Minnesota area.
Okay, thank you, Jim. John, next question for you. To supply the Westport HPDI engine, you need LNG?
Yes. Right now, the HPDI engine works on a very high-pressure fuel system. That the fuel system is operating at 4,500 psi. So what we do is actually pump liquid, cold natural gas out of the fuel tank and regasify it, but maintain it at a very high pressure. So yes, the HPDI engine uses cold LNG, and there really isn't a choice with that one to go to CNG because of the operating pressures of the fuel system.
Okay, thanks, John. Next question is for you as well. How about the advantages of natural gas as an engine fuel in terms of emissions?
Substantial advantages, at least on an engine-out basis, for both criteria emissions as well as greenhouse gases. Normally, criteria emissions, things like carbon monoxide, particulate matter, hydrocarbons, and oxides of nitrogen, are controlled with after-treatment systems. And so, diesel engines and other fuels used in either spark-ignited or compression-ignition engines can meet the requirements of government, but they do it by using expensive after-treatment systems. The nice thing about a natural gas engine is that it's got very low engine-out emissions. Therefore, it can generally operate with less costly or less complex emissions after-treatment systems. This is certainly true for the ISLG and the new ISX-12 spark-ignited engines, and to an extent, it is also true for the HPDI engine. So we have that big benefit that natural gas brings as an environmentally friendly fuel.
Okay, next question for Jim. Jim, can you please elaborate on the distinction between cold and warm LNG?
Yeah, and this is a struggle we had when we opened the very first large-scale station at the Port of Long Beach, where today we fuel about 1,500 tractors, both 9 liters, the beginnings of some 12 liters, and then the 15-liter HPDI. As John mentioned earlier, the HPDI has an onboard pump, and it operates and provides much better range on colder, unsaturated fuel. So at that station, we have an unsaturated tank that will provide fuel on 2 lanes for the HPDI trucks, and then on the other 4 lanes, we fuel a saturated warmer fuel with a higher vapor pressure because there is no pump. So the spark-ignited engines built by Cummins Westport, which is the 9 and the 12-liter, need a little warmer fuel, and therefore you sacrifice a little bit of range. But with that, though, comes a lot less complexity. You don't have to have a DPF or SCR, which saves weight and maintenance costs. But also, because of the simplicity of that system, you're only required to have a 3-way automobile catalyst in order to meet the EPA 2010 regulations. So one versus the other, I think eventually we're going to go to a single fuel. John's right, colder is better for us as an operator, but I want to be able to ensure that we keep simplicity for the truck owner. And so we have to balance that going forward. So today we're looking at a fuel probably somewhere between a saturated and unsaturated, where both advanced technology tanks and older technology tanks can operate.
Just like to jump in and add on that Westport has announced a new product that will be available later this year that we're calling it Ice Pack, and it's essentially a fuel tank for LNG that's designed to be used with spark-ignited engines that run on lower fuel system pressures, but that will allow the use of cold LNG. And the benefits, of course, are that it is simpler for our station providing friends, and it's also going to give longer hold times and about 10% more range for the vehicle, because the denser fuel, the colder fuel, really allows you to put more BTUs on board in the same amount of space. So that new tank is called Ice Pack. It'll be available later this year, and it will run on either vapor pressure or with a pump, and it's smart enough to know what situation it's in and what it needs to do. So it's got a very nice intelligent management system that allows it to optimize the use of the fuel on board the vehicle.
Thank you both. John, the next question's for you. What are the projections for getting the premium for a natural gas fueled vehicle down?
Well, I think that's already happening. We've seen that take place here over the last 5 years, and I think it will continue to happen. And it's happening across the board. We're seeing the reduction in cost of fuel tanks. And as we said earlier in the presentation, the fuel tanks are the largest component of the cost. And we're seeing both volume efficiencies starting to enter into that equation, as well as some technological breakthroughs that are helping to reduce the cost of fuel tanks. So that's happening. And then on the on-engine side, it's sort of the same thing. We're getting some volume efficiencies, and we're making, obviously, technological improvements in the engine to get more power, better fuel economy out of the same size engines and out of the same equipment, at least the same equipment cost. So I do expect that will continue to happen over time. And as I mentioned, we've already brought down the cost of a basic ISLG with basic storage capacity to something that really is quite obtainable in the $30,000 to $35,000 range. And I think it's at least within our line of sight at this point to get to something that's a very small increment over diesel for the engine itself, and then the fuel tanks on top of that, but they're getting better as well.
If I could just interject, what we see in the solid waste industry, we're projecting to happen in the heavy-duty truck industry. You know, I said earlier that Waste Management Republic are buying 80% of their new trucks as natural gas. But if you look back at 2012, we had more than a 50% market penetration into solid waste with natural gas. So of the 8,000 trash trucks that were built across the country, more than 4,000 were compressed natural gas. When we look back to 2007, when the ISLG engine was introduced, we probably had a $60,000, $70,000 incremental cost for 60 equivalent diesel gallons of CNG on top of the body. Today, Waste Management Republic are buying that same truck for about $20,000 to $25,000. So again, economies of scale, and it doesn't take a big number, but if you are able to give 1,000 to 2,000 truck orders per OEM, and there's 5 of them, so 10,000 trucks a year, you should be able to reduce that cost, which today is about $35,000 that John referred to, should come down to somewhere between $15,000 and $20,000 for a single tank, which will ride you a 400-mile range with reserve.
Thanks, Jim. We have time for one more question. Question for John, and Jim, if you want to jump in. Are there resources available for private businesses looking for contractors to do on-site fueling installation?
Yeah, there certainly are, and I think clean energy is a wonderful partner for businesses, and I'll let Jim talk about that a little bit. Westport offers Jumpstart, we call it, applications where if you need to get started right away with fueling, and you already have trucks or would like to put them into service immediately, we can provide temporary LNG or CNG fueling for you through many outside resources that are willing to jump in and do that. And then you can build your own station, and there's a tremendous amount of opportunity, in my opinion, to partner with other people or use companies like Clean Energy. And perhaps, Jim, you'd like to just add to that.
Yeah, and what we really recommend is free of charge is for us to come out and do an evaluation for your fleet, to look at your application, your duty cycle, understand how you do your job on a daily basis, and then present the opportunities and the facts of using compressed gas or liquefied gas, because we're unbiased. We do both. And in fact, in many cases, the customer wants to pay and build his own station. We'll do that and operate it if they like. Or if they'd like us to build it and turn it over to them and they operate it, that's fine as well. Or you can do that whole entire evaluation and fuel in our public network. But either way, there's strong economic advantages to start looking at alternatives to gasoline and diesel fuel if you're what I would call a high fuel consuming fleet. And today, based on today's incremental costs, fleets that are operating between 75 and 100,000 miles per truck per year or more are strong candidates for natural gas.
Thank you very much, Jim, and thank you, John. We appear to be out of time. I want to thank everyone who's joined us today on our webinar. As I mentioned before, we'll be sending out a link to the presentation for everyone to take a look at afterwards. We'll also send out the Q&A, particularly the ones that we weren't able to address during the Q&A period today. We did get a number of questions that we couldn't address today around shop maintenance, retrofitting, and that sort of thing, and we will actually be addressing a lot of those questions in our next webinar, August the 8th, Making the Shift to Natural Gas, Best Practices for Fleets. We'll also send a link along for registration for that webinar, and if you have questions around that, we'd encourage you to participate. So again, thank you very much, and we look forward to having you all on our next webinar in August.